Hello guys, so today I'm back with another video, and in this one we're gonna be dealing with special angles. So special angles are specific angles. These are the special angles: 0, 30 degrees, 45 degrees, 60 and 90 degrees. And you can see that from 0 the step is 30, then you have 30 degrees, then after that you add 15, which means it's 30, 45, 60, and then when you go to the last one again you add 30, 60 plus 30, it's 90. Okay, so these special angles in trigonometry are angles whose trigonometric value can be calculated without using a calculator. So these are the angles that we can be able to get their function values. What do I mean by the function value is, you know that your normal trig functions, if you take an angle and you substitute it in place of an angle as an input, the function is going to give out a trig ratio, right? So these angles are those angles that if you substitute, for instance in sine, if you substitute that particular angle, you will be able to actually give the expected output value without using a calculator. For instance, I know without using any calculator that if you substitute the angle 30 degrees in sine, you are going to get half, which is 1 over 2. And I did not use a calculator to actually get that function value. So how do we how do we get these function values without a calculator? Then I'm going to show you two special three in fact there will be 3 special right angles triangles that will help us to deal with these special angles. So the first 2 triangles are here for us, and we must make sure that they are in our head. So the first one, like we know, a right angle triangle will contain a 90 degrees, and you will be left with another 90 to fill other angles, because we know that angles inside a triangle add up to 180. So in the first one you have 45 degrees and 45 degrees, and then since the 2 angles are equal, you have then 1 and a 1. So this is an isosceles right angle triangle enamacala amabini angu 1 and the angles ezimbini ezingu 45 degrees and 45 degrees. And therefore you don't have to cram this side, because once you know this side and this side, then you can just use Pythagoras theorem to obtain this side, right? And then in this one, if actually, apologies for this one is actually 60 degrees, it's not 90. This is 60 degrees here. Okay, so in this one, the hypotenuse is 2, then and another side, the side close to 60 degrees is 1, right? So once you know these 2 sides, this side and that side, you don't have to actually cram this side. You can get it by using Pythagoras. But to me, it's always the easiest. Also this one, I call it a 3 to 1. I call it a 3 to 1, the way it's drawn. Next to 30 degrees, you have a 3, but a square root of 3. Then the hypotenuse is 2. Then this one, this side, the remaining side is a 1. I call it a 3 to 1, a special triangle, right? So I will keep on revisiting these special triangles as we work out some questions here. So I left out this space so that I can explain the third special triangle, which is not in the broader sense actually a triangle, because it's a triangle like this one, a right angle triangle, because we want to show how is 90 degrees and 0 degrees, how are they, those two angles actually special angles. So Nancy triangle, we draw this triangle, which is a right angle triangle, but this triangle contains 90 degrees here. And since this angle and this angle are already 180 degrees, it therefore means that the angle here is 0 degrees, right? But now if this angle is 0 degrees, that means this side is not there, right? So let's look at this. If the angle up there is 0, that means this side should also be 0. Why? Because if you have this, let's form an angle here. If this is 30 degrees, of course there will be a gap between this side and this side. But if we reduce the angle to 10, then the gap is going to narrow. The gap is going to narrow, which means we are going to get maybe something like this. Then we know that now we have 10 degrees. But if we are to even make that angle 0, then we are just going to have a vertical line. Because now the angle here is actually 0 degrees, right? So this triangle, in actual fact, this is how it would look. It looks like a vertical line, because this length here, it's not there. The length, this side is not there, because the angle up, this angle is 0. So it means that these two sides, this side and this side, should not be opening up. They're supposed to overlap, right? So in this triangle, you have that this side is 1 and this side is 1. Why are they both 1? Because of this angle is 90 and this angle is 90. Therefore, since these two angles are equal, these sides should also be equal, because they are sides that are opposite equal angles. Okay? Again, I will be revisiting this triangle as we work through some examples. Okay, so now the examples that we have sine of 90 degrees. So here straight away we need this degenerate triangle. And it could explain up. So I said, for the special triangle that contains 0 and 90, this is how it looks like. Apologies. So this is how it looks like. So you have a 90 degrees here, and you have a 0 there. This is 1 and this is 1. This is 0, right? The side opposite 0 degrees is 0. The side that is opposite the 0 degrees is 0. This side here. Okay? So now let us answer these first three, because we will, for these ones, we will need this triangle, right? We will need that triangle. So if we are then to let's apply our triangle now. So they are looking for sine of 90, which is opposite. Opposite is 1. Here is my opposite. The opposite of 90 is 1 over hypotenuse and my hypotenuse is 1, which is I have 1 over 1, which is 1. Tan of 90 is opposite. My opposite is 1 over adjacent 0. This is undefined. We cannot divide by 0. Okay? Sec of 90 degrees. Sec is the reciprocal of cos. So it's going to be hypotenuse, which is 1, over adjacent, which is 0. Again, we have undefined. Right? And then for these remaining questions, these two, we need the other two special triangles. So I will put up the two special triangles here. The first one, which I like the most, is the 1, 1, just like this one, right? It's 1 and 1. So there's 1 this side and this side is 1. This is 45 and this angle is also 45 degrees and this is 90. And then the other one is the one with 30 and 60. Right, so there's 60 here, there's 30, then next to 30 degrees is square root 3. Remember the 3 to 1, then there's a 2, then there is a 1. So we can then use these two. And then for this one, cos of 45 degrees, I have to use the special triangle with 45. Cos is adjacent. Remember this side is square root 2. So cos of 45 degrees is adjacent, which is 1 over hypotenuse, which is square root 2. And then for this one, we know that it's equal to bracket cos of 30 degrees squared, which is equal to cos of 30 adjacent square root 3 over hypotenuse, which is 2. Square this, you get 3 over 4. So this is actually a perfect set of examples where we needed all the 3 special triangles. So sisebenzise zontathu special triangles zethu apha. So you can see that if ungena kwi-exam uzazi ezi special triangles, then you will be able to deal with those 3, 4, 5 marks questions where you need to apply the special triangles, and they will even state that without using a calculator. Okay, so let us move to some more examples. So this is a typical question. This is a typical exam question. Let's see. Okay. So in this question, what are they looking for? They are looking for calculate the value of the following without using a calculator. So if you look at the special angles that we have here, we have a 30, 90, 90. So we need 2 special triangles. So the first one is the degenerate, the triangle that is not really a triangle, okay, which looks like a vertical line. So I have 0 degrees. Opposite 0 is 0. Then I know that this side will be 1 and this side will be 1 because I have 90 here and I have 90 also here, right? And then the one with 30, it's also my favorite also because of the 3 to 1 rule. I know that 30 degrees is here. Then next to 30, I have a 3, but a square root, and then I have a 2 and a 1, right? Okay, so now I can tackle this question, and I think this question would be out of 4 or maybe out of 3, because you should get a mark for getting this value, a mark for that value, a mark for that value, and then a mark for the answer, right? So sine of 30 degrees, there's 60 here, sorry, in this triangle there's a 60 there. Okay, so sine of 30, sine is opposite, which means, like I said earlier on, it's gonna be half. I was actually using this triangle here. So sine of 90 degrees, sine of 90 degrees is opposite, which is 1 over the hypotenuse over 1, plus cot of 90. Cot of 90 is, remember, cot is the inverse of, but this will be squared. Cot is the inverse of sorry, is the reciprocal, not inverse. Apologies about that. Is the reciprocal of tan, which means it's going to be adjacent over opposite. Adjacent is 0 over 1. If you look at this, it's telling us that even though tan is undefined at 90 degrees, the reciprocal of tan is not necessarily undefined at 90 degrees. Can you see that? So if you look at this, you can just press it as it is, substitute correctly, write it as it is in the screen of your calculator, and you will get that the answer here is 1 over 2. All right? So let us move. And like I said, you would get maybe a mark here. 1, 2, 3, 4. And you have 4 good marks. Okay? So let's move. There's another one out of 4. So here we need 2 special angles. The one with 45, the easiest. 1 and 1. I know that this is square root 2. I have 45. I have 45 degrees here also. I have 45 degrees. And then I need the one with 60 and 30. 60 here. Then I have 30 here. Of course, 90 is the 3, 2, 1, square root 3. Then I have 2, then I have 1. Okay? So straight away, sine of 45 degrees is opposite over hypotenuse, so it's 1 over 2. I'm dealing with the numerator now. And then sine of 60 is opposite, so it's square root 3 over 2. Remember, I'm jumping between the 2 triangles because I have to respond according to the needs of the trig function that I am using. Since now I have an input that is 60 degrees, I have to use this special triangle. Then when I had 45, I had to use this special triangle. So again, let's move to the denominator. Cos of 45 degrees is adjacent, which is 1 over square root 2, right? And then let's see what we get there. You can press it as it is in your calculator. I'm actually searching for mine here. I'm actually searching for my calculator. But if okay, it's here. I was about to do it manually. Okay, so you have 1 over 2 times bracket square root of 3 over 2 close bracket squared over 1 over the square root of 2. I am getting 3 square root 2 over 8, but I will also try to work it manually to see if I agree. Okay, if I work it manually, Remember, you don't have to work it manually. Okay, my pen is not responding. I have to put it back. Have to try to recharge it a bit. Okay, yes, now it's connected. I want to believe. Yes, they are saying that the pen is low. Okay, so I will try to do it manually. Then I will have 1 over 2 times 3 over 4 over 1 over square root 2. I know that in the numerator I will end up with 3 over 8. Then I can multiply it with the reciprocal 2 over 1. So the calculator is correct. The answer is 3 square root 2 over 8. They are correct. So you don't have to work it manually. You can use your calculator as long as you are good with your calculator skills. The next question is calculate the value of the following without using a calculator, of course. So here I need the 2 again. I need the 45. So I know that I have 45 here, 45 here, 90. These two angles are equal, so this is 1 and 1. And then I have square root 2 here. Then I go to the 3 to 1. The 3 to 1, I have 30 here, I have 60, I have 90, then I have 3 to 1, then I get to it. Okay, so cos of 30 degrees is adjacent, which is square root 3 over 2, bracket, multiple times, tan of 60, opposite, which is square root 3 over adjacent, which is 1, plus cosec squared. Cosec is the reciprocal of sine, which means it's going to be hypotenuse over opposite squared times sine of 60, but squared. So sine of 60 is square root 3 over 2. You can just substitute it as it is in your calculator and get the final answer. I'll try to do it manually. I will get for these two, I will get 3 over 2 plus that side, I will get 6 over 2, which means that I will end up with, I will not simplify this one because it's going to make my work easy if I don't simplify it. I'm going to get 9 over 2, right? You can actually verify with your calculator. So actually it's 3 marks. So surely here there will be 1 mark for these two, 1 mark for these two, 1 mark for those two, and then 1 mark for the answer to get 3 marks. Okay, so we have this one. So in this one, they want us to deal with 45, 60, 90, so we need all three. I will start with the easiest, 45. I have 1 and 1 and square root 2. Then again, the easiest will be this one, which is 90 and 90 and 0 degrees here, which is 1 and 1 and 0. Then I will go to the 3 to I have 30 here, 60 in terms of the angles. Then I will have the 3 to 1. Okay, so cosec reciprocal of sine, so it's going to be, I'm going to use the one with 45 degrees, the special angle with 45 degrees. So it's going to be a hypotenuse over opposite. That's my numerator. Over sine of 90. Sine of 90, I'm sure that you can agree with me that it's 1 over 1. and tan of 60, it's going to be square root 3 over 1, and you can just punch it in your calculator as it is. I will try to work it manually. I have square root 2 over square root 3. Your calculator might give you, let me check, it might give you square root 3 times square root 2, might give you square root 6 over 3. It has rationalized the denominator. Okay, it's 4 marks, so I'm sure there's 1 mark for this one, 1 mark for this one, 1 mark for this one, and 1 mark for that one. And then you end up with 4 marks. I extract these questions from past papers, so it also depends on the examiner and the level of the learners of the examiner, if the examiner is a teacher, in terms of how the marks are allocated. So we have this one now. In this one again, you can see that we need the 2. We need the one with 45, the easiest. There's 45 here, 45 here, 90, then there is 1 and 1, then square root 2. Then we go to the 3 to 1. The 3 to 1, you have 30 here, 60, and then you have the 3 next to 30, 2, and a 1, and we start working. So sine of 30 degrees, I think now we all know that it's half. And then cot is the reciprocal of tan, so it's going to be adjacent over opposite over cos of 30 degrees is going to be adjacent, which is square root 3 over hypotenuse, and then tan of 60 is going to be, let me see, tan is opposite over adjacent. So the answer here, we have 1 over 2 in the numerator over 3 over 2, which is the same thing as 1 over 2 times 2 over 3, which becomes 1 over 3. But you can use your calculator to get this one again. It's out of 3, so I think will be 1 mark for the numerator, 1 mark for the denominator, 1 mark for the answer to get 3 marks. Okay, so let's move to, I think this will be our last example. Let me quickly check. Yes, this will be our last example. So we need the special angle with 60. So with 0, 60 and 45. I'll start with the easiest, which is the 45 one. 4, 5 here, 4, 5 here, and I have 1 and a 1 and the square root of 2. And then the one with 0 looks like this. You have 0 degrees and you have 0 this side. You have 90 and 90, then 1 and 1. And then the 60 degree one, you have a 30, a 60 inside, a 90. Next to 30 you have 3, which is square root 3, 2, and a 1. And we start working. Cos of 0. So I am here, cos of 0, cos is adjacent, which is 1, so I have 1 over the hypotenuse, which is also 1, right? Plus sine squared of 60, sine of 60, I'm here. Sine is opposite square root 3 over hypotenuse, which is 2 squared, plus square root 2 times sec of 45. Sec of sec is the reciprocal of cos, so it's going to be adjacent, which is 1 over the hypotenuse, which is square root 2. Then I'm going to end up with 1 here, over 1 plus plus 2 plus 3 over 4 plus 1, which simply means that I have 2 plus 3 over 4, which means that I have, this is over 1, I have 4 in the denominator, 4 times 2, this multiplies that, this multiplies that. I have 8 plus 3, which gives me 11 over 4. But you can use your calculator straight away to get the answer, like I have been saying, so that you don't lose marks in all these steps here. But I am doing them for those that may want to do it manually. Okay, so marks here, you have 4 marks. The allocation is surely going to be maybe, let me look at it, I think it's going to be maybe 1 mark here, 1 mark here, and then 1 mark for this one, and then 1 mark for the answer, to end up with 40 degrees. Can I take this off just to make sure that it's not too dirty? Okay, so that is the end, guys, and I'm hoping to see you soon with another video. Please, as always, like, subscribe. If you haven't subscribed, you are welcome to comment to help the channel to grow with your inputs. Also, please share the links to everyone that is doing maths. Doesn't have to be grade 10, because some of these concepts are actually examined in grade 11, grade 12, and there is not enough time for the teachers to cover these concepts, because they will know that you have covered these concepts in previous grades. Okay, thank you, guys. See you soon.